Now we call it the 5% rule because we can only do this if the X value you get is less than 5% of the original concentration. Because if it's more than 5%, then the X is going to be too big to assume that it's 0, and it changes that number more than we want it to. So when you get an X value divided by the original concentration of the acid, and it's got to be less than 5%. So what we're doing is this: 5.9 times 10 to the negative fifth over 0.1 times 100. The question is that less than 5%? The answer in this case is yes. I think you can tell that.
So you don't do the 5% rule until you calculate it using that method?
Yeah, go ahead and use this method and calculate the X value and then check it. You're going to see when you start doing these problems in the solution guide, for a lot of these, they're going to be using the 5% rule, and then they're going to really check the 5% rule, and they'll say, like, assumptions are good. That means that we assumed it less than 5%, and it was. Kyle?
Wait, but we really can't check for a 5% rule until we get that final number, though.
Right. I'm going to give you something in general. If your K is less than 10 to the negative fifth or less, it's a pretty good bet to use the 5% rule. 10 to the negative fifth or less.
I got 6%.
What?
She's trying to burst the envelope.
That's divided by that? That's 10.
5.9 times.
I thought it was 0.6%. No?
Did you multiply that 100? Yes.
Are you sure?
Did you hit the enter key?
This is 10 to the negative eighth gives us 6%.
No way.
I got this, guys.
10 to negative.
She's bad at
Oh,
saying.
wait. 0.059%.
Oh, God.
Nuts!
You can just put in
Oh! Wait, it's two. Wait. How many sig figs are there? There's one sig fig. Wait.
It
doesn't matter. You should have two. Well, yeah, I guess it was. I just made that short. How would that be 6%? My gosh, if you have.
Eric got
Yeah,
0.6.
0.06%.
Rashid just is bad at math.
Whoa.
But it's 0.00059, so like moved it. Yeah.
Look, Kyle, look.
What? What's up? Okay, so we get 5 to the power negative 5 divided by.
Only to work this out.
And then
Thanks.
I didn't have to check. They just trusted me.
Oh.
We don't do that. We don't do that in this class. Ever since Mono Pro.
Wait, do you divide?
Come
by
on, there's all these people in this class.
Wait. Do you divide by
What do I
0.1 or do you divide?
Yeah,
or do
divide
you
by
times
0.1.
There's a line!
Oh my god. I don't have my calculator. Tarun put it in the back of the
So
room.
5.9%.
No, 0.059%.
Should I be recording all of this?
Yeah, Drew, never mind any of this.
Because you did this, Rashid.
It's like 6%.
You're supposed to divide.
Let's make like a 20%.
Yeah, not 5.9.
We are way under 5%. These guys are just fumbling.
Let me try it.
We're 6.
Wait, this
We're
is
at
more?
6.
Oh, wait.
We're at 5.9%.
Since you're dividing by 0.1 and then times it by 100, couldn't you just say times 1,000?
Yeah, but that's just to find the percent.
Yeah.
And that would be 5.9 times 10 to the negative 2%.
Oh,
If you don't multiply another 100.
0%. That's a percent.
Oh my
So that's
god.
12.
Okay, alright, we need to
That's not
stop
actual
now.
Are we done
Can
now?
you stop? Thanks.
Huh?
We're okay with this. Most of us are.
I gave it that.
So, we don't have an answer yet. You have to keep in mind what the question was. The question was, what is the pH? So, we found the X value, which is the hydrogen concentration. That's that number right here. So, you take negative log of that X value. That's what the pH is. It's 4 point something. You okay with that?
Maybe.
The negative log of 5.9 has negative 10 to negative 6.
Yep. Practice these. Try some of the strong acid problems first. Get to some of the weaker acids, and it'll go in order in the problems. Spencer, let's move on.
Do you have to move it down? Or
Nope. Yeah, it just had the K expression. Now this is a typical Dumno problem. It does not just have one answer. This one has 4 answers.
No.
Could be worse. Find the concentration of all species present. There's our first 3, and then find the pH. There's our 4th answer. Now they're asking us to find the pH of an HF solution. I will tell you, HF has a unusually high Ka value. It's 10 to the negative 4.
Dang it, no 5%.
No 5% rule allowed.
Mr. Moore.
Okay.
Why? Why does this happen to us?
Oh, what is
Can someone tell me the Ka to go to?
Hey, I'm going to tell you this, because the initial concentration makes a difference too, as compared to the Ka. I told you before, use a Ka when it has a 10 to the negative 5th or less. That should be okay to use the 5% rule. But I'll tell you this more specifically, and if you're good at math, you'll understand.
Okay.
If the concentration initially is 10 to the 4th power different from the Ka value, 10 to the 4th different, like 4 powers of magnitude different, then use the 5%.
Wait, what?
Wait, what?
Come again.
That means you're not good at math.
Repeat that again because I was blanking.
Okay. Normally you're going to get
Blinking.
small concentrations. Like in this case, you see how small the concentration is? 0.02. The Ka value is 10 to the negative 4th. That's only 2 orders of magnitude difference. Don't try the 5%.
So if there's a
difference of 4 powers of magnitude, try the 5% rule or more. Okay. So like in the last example, it was the initial concentration was 0.1. That was 10 to the negative 1st. The Ka value is 10 to the negative 8th. So you were definitely able to use the 5%. There's a difference of 10 to the negative 7, 10 to 7.
Yeah.
All right. Now, shall we do this or not bother?
Not bothered.
Let's not do the work. All right. Now, let's just talk about how we would do it. You have 0.02 right here, 0 and 0. So minus x and plus x. You have 0.02 minus x, x squared on this side. You would take the Ka value, which is 7.2 times 10 to the negative 4th, you can look it up, equals x squared over 0.02 minus x, and away you go with the quadratic formula or the graphing method. How many of you are using the graphing on your calculator?
Every single time.
It's fast, right?
Very.
If you know how to use it, how many of you are going through the quadratic formula?
it's not that hard.
How many of you that use the quadratic formula find it very, very annoying and you hate using it? Let me see your hands for that. How many of you that use the quadratic find it not to be a big deal? You don't mind using it?
You just do
Okay.
Like a trick to doing it is find the discriminant first.
You just like to short it.
Oh, you do quadratic formula, okay.
Yeah, find the
All right.
Calculator right now.
Spencer, go to the next one. Now it's almost time to go. Can I have your attention, please?
Plus or minus the stupid line.
Just want you to see this. We're not going to go through the whole problem. But if you're motivated and trying to do some of the problems, get them behind you tonight, you're going to come across some percent dissociation problem. Percent dissociation is similar to what we just did testing the 5% rule. In fact, it's the exact same. The percent dissociation of an acid is where you take the acid, you find the X value and come up with the equilibrium concentration of hydrogen. And if you take that concentration of hydrogen divided by the initial concentration, that'll tell you what percent, and multiply by 100. That'll be the percent of the acid that dissociated. Really, it's the same as the calculation for the 5% rule.
Okay, so basically take the final of the H plus.
Yeah, take your X value, which is going to be the H, divided by the initial concentration. And for weak acids, it's a small number, 3%, typically, or around there, 1%. But there's often percent dissociation problems on the AP exam. Don't blow these off.
So when
They're not terribly hard, just know how to do them. Yeah?
When we're looking at these Ka values, are they giving the Ka values of the acetic acid or like acid?
Of the acid. Yeah.
Am I good?
We're good, yeah.